So from typical Mendelian dihybrid cross in F2 generation, we have reported yellow round seeded plants 9, yellow wrinkle seeded plants 3, green round seeded plants 3, and green wrinkle seeded plants only 1. Now, based on the data that is available here, we can get some objective questions in the form of problems. What is the ratio of yellow seeded to green seeded condition in F2 generation of a typical Mendelian dihybrid cross. So let me read the question. What is the ratio of yellow seeded to green seeded condition in F2 generation of a typical Mendelian dihybrid cross? You can use this data. We have taken the color of the seeds into consideration. So, in this case, 9 of them are yellow seeded. 9. Even 3 in the second case is yellow seeded. So, the total number of yellow seeded plants, yellow seeded, is 9 plus 3, that is 12, and the total number of green seeded plants, how many of them are green seeded? In this case there are 3 green seeded and here 1 green seeded. Therefore, green seeded is 3 plus 1, that is 3 plus 1 is equal to 4, 1 is to 4, 1 is to 4 is nothing but 3 is to 1. To try to understand, time saving is also an important factor in objective examination. When you go through the question, only one character is taken into consideration, that is the color of the seed. When only one character is taken into consideration for a cross, then it is a monohybrid cross. When it is a monohybrid cross, obviously the ratio is 3:1. If it is a phenotypic ratio, so the ratio is a phenotypic ratio. You can repeat the same question. Instead of the color of the seeds, you can take the shape of the seeds. You can repeat the same question with the shape of the seeds. What is the ratio of, instead of yellow seeded, I will put round seeded. What is the ratio of round seeded to, instead of green, I will take a wrinkle seeded. What is the ratio of round seeded to wrinkle seeded condition in F2 generation of a typical Mendelian dihybrid cross. So how many of them are round seeded? In this case 9 of them are round seeded, and in this case 3 of them are round seeded. Therefore once again the round seeded is again 9 plus 3, that is equal to 12. And wrinkle seeded, in this case the number of wrinkle seeded plants are 3. Here 1, 3 plus 1, it is 4. So wrinkle seeded is 4. Once again it is 3:1. When you plug both the characters, then we get the dihybrid ratio. So monohybrid ratio is 3:1 for round seeded versus wrinkle seeded, and for yellow seeded to green seeded the ratio is also 3:1. Therefore it is equal to 9:3:3. So this is how we can cross check the problems. So these sort of problems will appear in the NEET examination. Okay. So now we are going to work out one more problem based on the data available. In a typical Mendelian dihybrid cross, F2 generation, 1600 plants are produced. 1600 plants are produced. How many of them are homozygous for a single character? How many of them are homozygous for a single character? Now this is the question. In a typical Mendelian dihybrid cross F2 generation, 1600 plants are produced. How many of them are homozygous for a single character? So this part of the question plays a crucial role. To read the question, how many of them are homozygous for a single character? Once again you have to make use of this checkerboard. This is double homozygous. So don't take this into consideration. Double homozygous. This is heterozygous and this is homozygous. Therefore, it is homozygous for a single character. So you can take this. This is heterozygous, this is homozygous. Therefore, this is also homozygous for a single character. This is double heterozygous. Therefore, it is not taken into consideration. This is double homozygous. This is homozygous, this is homozygous. We want homozygous for a single character. So, this is not taken into consideration. This is heterozygous and this is homozygous. So we have only one homozygous condition. So So you can take this into consideration. Then here it is a double homozygous. Double homozygous. Don't take this into account. This is single homozygous. This is heterozygous. This is homozygous. Take this into consideration. This is a double homozygous. This is not taken into consideration. Now count the total number. The number of homozygous condition for a single character. 2 here, 2, 2, and here 2. That means 8 out of 16. 8 out of 16. If 8 individuals are homozygous for a single character, 8 out of 16, in 1600, how many of them? Means half of 1600. 8 is half of 16. Half of 1600 is 800. Just you put 8 by 16 into 1600. It is 100 times, that is 800. So half of 16 is 8. So out of 16 plants produced in 2 generations, 8 plants are found to be homozygous for a single character. So if 1600 plants are produced in F2, so it is half of 1600, that is 800. So in this way you have to do the problems. Now I will make a small change in this. This is a how many of them are, instead of homozygous, I will use double heterozygous. Double heterozygous for double heterozygous for 2 characters. Double heterozygous. Now let me read this. This is double dominant, double homozygous. So don't take this into consideration. This is single heterozygous. We want double heterozygous, so it is not correct. This is also single heterozygous. It is not correct. This is double heterozygous. This is heterozygous. This is also heterozygous for 2 characters. What are the 2 characters? One with respect to the color of the seed and the other with respect to the shape of the seed. So, how many of them are double heterozygous for 2 characters? It is 4. 4 out of 16. 4 out of 16. How many plants are produced? The number of plants produced in F2 generation is 1600. Therefore, 4 out of 16 means it is 1/4 of 16. 1/4 of 16. There are 4 by 16 into 1600. It is 400. So 400 plants are double heterozygous for 2 characters. Double heterozygous for 2 characters. So in this sense, you are going to get objective questions in NEET examination. First, you must thorough with the checkerboard of a double dihybrid class, and you must take patience to note down even for getting 4 marks. Getting 4 marks is not easy. So we need patience to put it on your paper. You have a rough space available. You spare time for 1 minute, then you can work out the problem. Otherwise, whenever there is a problem of recalling the things mechanically, there is every chance of committing error. So my suggestion for you is spare a little time to represent this, then work out the problem that is given. Then you don't have any confusion and you are sure of getting the right answer and getting 4 marks for the right answer. So for monohybrid class, first is a monohybrid. The phenotypic ratio is 1:3:1. 3:1. Whereas the genotypic ratio is 1:2:1. 1:2:1. For monohybrid class, the test cross ratio is 1:1. 1:1 is the test cross ratio for monohybrid class. For dihybrid class, what is the phenotypic ratio of a dihybrid class? Means you can work out as 3:1 into 3:1. Now we will get 9, 3 is 9, 3 into 1, 3, 1 into 3, 1 into 1. So 9:3:1. And for genotypic ratio of a dihybrid class, it is 1:2:1 is to 1:2:1. 1:2:1 into 1:2:1. We will get the genotypic ratio as 1:1. 1:2:1 is to 2:4 is to 2 is to 1:2:1. This is dihybrid genotypic ratio. Then for dihybrid class, what is the test cross ratio? You can just use 1:1 is to 1:1. So you are going to get the ratio as 1:1:1:1. So this 1:1:1:1 is dihybrid test cross ratio. 1:1 is a monohybrid test cross ratio, whereas 1:1:1:1 is dihybrid test cross ratio. Now let us imagine a tri-hybrid cross. This is only an assumption, a tri-hybrid cross. When a cross is made between two individuals, by taking into consideration of when a cross is made between two individuals differing in three characters, then it is called tri-hybrid cross. So for a tri-hybrid cross, you just use the logic and get what is the phenotypic ratio of a tri-hybrid cross, what is the genotypic ratio of a tri-hybrid cross, and what is the test class ratio of a tri-hybrid cross. Now, for a tri-hybrid cross, what is a tri-hybrid cross? Tri-hybrid cross is monohybrid into dihybrid. What is the monohybrid phenotypic ratio? It is 3:1. This is a monohybrid phenotypic ratio. And what is dihybrid phenotypic ratio? 9:3:3:1. Now make the multiplication. 9 into 3, 27. 3 9s 27 is 2, 3 3s 9, 3 3s 9, 3 1s 3, 1 9 9, 1 3 3, 1 into 3 3, 1 into 1. In monohybrid cross, the number of progeny produced in F2 generation is 4. In dihybrid cross, it is 16. Whereas in trihybrid cross, it is 64. You can count 27 plus 9. 27 plus 9 is 36. 36 plus 9, 45. 45 plus 3, 48. 48 plus 9. 48 plus 9 is 57. 57 plus 3, 60 plus 3, 63 plus 1, 64. So, in a trihybrid cross, F2 generation, the number of offspring produced is 64 in the ratio of 27:9:3:3:3:1. In the same way, you can work out the genotypic ratio too by multiplying the monohybrid genotypic ratio, that is 1:2:1, with that of dihybrid genotypic ratio. What is the dihybrid genotypic ratio? 1:2:1 is to 2:4:2 is to 1:2:1. Now you are going to get a big ratio for this. 1:2:1. Everything is multiplied by 1. Is to 2:4 is to 2 is to 1 is to 2 is to 1. Now every factor is multiplied by 2. 2:4 is to 2:4 is to 8:4 is to 2:4 is to 2. Once again, 1:2 1:2:1. This is a big ratio of a trihybrid process. So you should know the logic of getting the ratios. The logic of getting ratios, even if you count, you will get 64. The total number is 64. And the total types of genotypes. The total number of offspring is 64 in trihybrid cross. The total types of genotypes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 19, 20, 21, 22, 23, 24, 25, 26, 27. That means the total types of genotypes, the number of types of genotypes in a trihybrid cross is 27, and the total offspring produced in a two generation of a trihybrid cross is 64. And the trihybrid cross genotypic ratio is this. This is the trihybrid cross genotypic ratio. And similarly, if you want to work out the trihybrid cross test cross ratio, you can multiply 1:1 with 1:1:1. You are going to get trihybrid test cross ratio as 1:1:1. So, once you understand the basic concept of how to express the ratios, then you can easily work out what is the phenotypic ratio for a trihybrid cross based on the ratios of monohybrid and dihybrid. And similarly, the genotypic ratio of a trihybrid cross based on the ratio of the genotypic ratio of monohybrid cross and dihybrid cross. And similarly, the test cross ratio of a trihybrid cross based on the test cross ratio of monohybrid and dihybrid crosses. So, you should develop this sense to work out the objective questions in Mendelian cross. Based on Mendelian dihybrid cross and the results obtained, Mendel proposed the second law of genetics, that is the law of independent assortment. So on the basis of dihybrid cross, Mendel proposed the second law of genetics. The second law of genetics is the law of independent assortment. The law of independent assortment. And what is this law of independent assortment? Or how to define this law of independent assortment? When two or more contrasting pairs of characters are brought together in a class. When two or more contrasting pairs of characters are brought together in a class, the inheritance of one contrasting pair of character is independent of the other. That means, in dihybrid class, we have selected two characters. One is the shape of the seed and the color of the seed. The inheritance of the shape of the seed is independent of the inheritance of the color of the seed. Now let me put the definition of law of independent assortment. When two or more pairs of contrasting characters are brought together in a class. Let me write. When two or more pairs of contrasting traits are brought together in a class, the inheritance means transmission. The inheritance of one pair of contrasting traits is independent from the other. That is the law of independent assortment. Let me explain further for better understanding. In a dihybrid class, we have chosen two characters. One is with respect to the shape of the seed, and the other is color of the seed. Color of the seed and shape of the seed. We try to recollect the genes or its alleles responsible for the color of the seed. The genes or its alleles responsible for the color of the seed are located on the first pair of chromosomes in Piv plant. And similarly, the genes or alleles responsible for the shape of the seed are located on the seventh pair of chromosomes. Just try to have a recollection. We have discussed already. The genes or its alleles responsible for the color of the seed are present on the first pair of chromosomes, and for the shape of the seed are present on the seventh pair of chromosomes. That means the genes or its alleles located on two different chromosomes. Let me put two different chromosomes are assorted independently. This is the law of independent assortment. And this law of independent assortment holds good. It holds good when the genes are located on non-homologous chromosomes. Remember, it holds good when genes are located on non-homologous chromosomes. The law of independent assortment holds good when genes or its alleles are located on non-homologous chromosomes. What are non-homologous chromosomes? Different chromosomes. I said the gene for the color of the seed on first pair of chromosomes, and the gene for the shape of the seed are located on seventh pair of chromosomes. So the first pair of chromosome is different from the seventh pair of chromosome. Therefore, they are non-homologous chromosomes. So the law of independent assortment holds good when the genes or its alleles are located on non-homologous chromosomes. That means on different chromosomes. So that is law of independent assortment. In examinations, you will be given an essay question for 8 marks about the dihedral class. Sometimes they will give the combination in the question also. When a tall pea plant with round seeds, there is no hard and fast rule that round yellow seeds versus wrinkled green seed class should be given for your examination. When a tall pea plant with rounded seeds is crossed with a dwarf pea plant with wrinkled seeds, how will be the progeny in the F2 generation, and define the law based on the results obtained? This is the question. So you must be in a position that The question is related to the dihybrid cross, and you have to use appropriate symbols based on the data given in the question. Then you should follow the basics of the dihybrid cross. Then frame a checkerboard, obtain the results, then analyze the results. I have showed the way of analyzing the results of a dihybrid cross, and at the end you have to define what is the law of independent assortment. The law of independent assortment, let me repeat, it holds good when the genes or its alleles are located on non-homologous chromosomes. And the law of independent assortment states that when two or more pairs of contrasting character traits are brought together in a cross, the inheritance of one pair of contrasting traits, that is the inheritance of, say for example, the color of the seed, is independent from the other, means the inheritance of the color of the seed is independent from the inheritance of the shape of the seed. This is possible because the genes or its alleles are located on two different chromosomes. That is, the genes for color of the seed are located on first pair of chromosomes, and for the shape of the seed are located on seventh pair of chromosomes. That is all about the dihybrid cross. So you must work very hard. You must work very hard, wholeheartedly, to understand the basics of the dihybrid cross. To understand the basics of the dihybrid cross, usually in NEET examination, some questions related to dihybrid cross will be asked. In previous NEET examination also, questions related to dihybrid cross were asked. Questions related to dihybrid cross were asked. Now, we are going to discuss some more points related to dihybrid cross. When you observe the phenotypic ratio of the dihybrid cross, what is the phenotypic ratio of the dihybrid cross? The phenotypic ratio of the dihybrid cross is 9:3:3:1. This is a recollection. The phenotypic ratio of a dihybrid cross is 9:3:3:1. Out of 16 offspring or progeny produced in dihybrid cross F2 generation, 10 of them, 9+1, are non-recombinants. We have discussed in one of my classes what are non-recombinants, and 6 of them are recombinants, 3+3 recombinants. That means in dihybrid cross F2 generation, we have seen recombinants also, but we haven't seen the recombinants in monohybrid cross. What is the reason for recombination of characters? For recombination of characters, crossing over is the reason. Crossing over. Now, what is a crossing over? Crossing over means the exchange of genes. The exchange of genes between non-sister chromatids of homologous pair of chromosomes. That is crossing over. Crossing over is the exchange of genes between non-sister chromatids of homologous pair of chromosomes. This crossing over results in recombinants. This crossing over results in recombinants, and this crossing over happens during packaging stage of meiosis. Packaging. It happens during packaging stage of meiosis. So during packaging stage of meiosis, there is exchange of genes between non-sister chromatids of homologous chromosomes that results in recombination of characters resulting in recombinants. Sometimes a question is framed: which stage of meiosis is responsible for the appearance of recombinants in F2 generation of a typical dihybrid cross? Means it is a packaging stage of meiosis. The packaging stage of meiosis is responsible for the appearance of the recombinants in the dihybrid cross. So you try to recollect what is a crossing over. You will come across a crossing over in cell division during meiosis. It happens during packaging stage.